Welcome to qnawire.
So we're asked how did the following quantity change when the simple ideal Rankine cycle was modified with regeneration and assume the same mass flow rate through the boiler. So we're kind of comparing apples to apples again. Um, it turns out that the moisture content remains the same. Um, Again, if everything else is the same, if all the pressures and stuff are the same, so that's going to be the same because well, yeah, it's just the way those things work. It'll be the same if you have the same pressure. If have everything the same, but instead of just bleeding off some, the moisture content at the exit of the turbine will be the same. But in what happens in the regeneration case is that everything else decreases, which sounds bad, but we decrease the work less than we decrease the heat supplied. So that means that we get a higher efficiency. Okay, and in fact, if you have something like a ratio of x over y, and you subtract off, you know, z from both the numerator and denominator, um, you're going to get a larger fraction. So again, you're just basically, if you subtract the same amount off both top and bottom, you get a higher efficiency. So you'll get less work out of this system, but you supply it with less heat. And again, it works out so that if you do it properly anyway, you'll get a higher efficiency. Like I said in the previous case, if you just bleed off everything before it goes through the turbine, then you're going to get a whole lot less work, but you're gonna basically get a whole lot less heat supplied, but then the work is going to be zero, and so it doesn't matter. You're going to have an efficiency of zero. So you can't just bypass the turbine by bleeding everything off beforehand, or by bleeding everything off before it gets to the outlet of the turbine. So again, up to a point, it makes sense to bleed some off um, and reduce the work output, but then reduce the heat supplied, the heat needed also.